Hello, and welcome to the MPLS lab training. I'm Craig Hammond. I'll be going through a number of videos that explain how to set up an MPLS network, which is a common technology service providers use in the industry today. We'll demonstrate how to configure the MPLS backbone, along with the necessary configuration for the customer networks that will connect to the MPLS backbone. Additionally, I'll cover some advanced features such as Layer 2 Ethernet services and IPv6 support over an MPLS backbone. And I will go through these steps and configuration on actual hardware and take you step by step and explain each command as we go so that we know exactly how to set this up. I'll be switching between the design diagram and the configuration command line. So let's first start out here with the MPLS topology, the topology we'll be working with. This is the generic tab here, just kind of gives an overview. And zoom in on it here a little bit. Basically what we've got is we're going to have two different customers. Each customer is going to have a separate site. So for example here we've got customer A, they've got site 1, that's up here on the top. And down below we're going to have customer A site 2. And that the same thing will happen with another customer, will be customer B site 1 and then customer B site 2. We have that. Here is the in the middle, the MPLS backbone. We'll be configuring that. And that's basically what the topology is going to look like. So let's go ahead and look at the detailed the topology, because that's mainly what we're going to be working off of here. Okay, so this is the detailed topology. This is actually what we just saw in the other high level overview. However, it's got a lot more detail to it, and this is what we'll actually be using as we go through building the configuration. So let's just go ahead and get a little lay of the land here. I'll explain each of the different areas. So as we work with this back and forth, you'll notice some of the terms that I'm referring to, and it'll make a little bit more sense. Okay, so what we've got here again in the center, we've basically got these two yellow routers. This is a Cisco 2921. This is what we're going to call PE1. Now PE stands for Provider Edge. That's going to be where we actually have an MPLS configured and where we'll hand off to the CE, which is basically called the Customer Edge. So the two yellow ones here are the MPLS backbone themselves. So PE1 and PE2. Let's just zoom in on that a little bit here so we can see what we have. So PE1 is going to connect with PE2 with 2 gigabit Ethernet links. So we're going to have gig 00, that's going to be connected back and forth, and then we're going to have gig 000. Now you'll notice that there's some red and blue dots on here. So let's go ahead and go down to the legend, and you'll see in the legend the red dot is going to be BFD adjacency. That's a bidirectional forwarding detection adjacency, and then we've also got LDP, which is a label distribution protocol adjacency. So we'll get into that a lot more as we get going on these videos, but those are some things we're going to set up there. You can see the way that this is built out. We've got the IP addressing assigned. We've gone ahead and we've got on for example gig 00 here, we've got the 10.0.1.0/30 network, and that's what we're going to allocate there. Dot 1 from that network will be assigned to the gig 00 link on PE1. And then down here below, dot 2 will be assigned to PE2. So you can see that on the other interface we also have a similar address. We've got the next one available, which is 10.0.1.4. And then PE1 will be the lower number, it'll be dot 5, and then PE2 will be the higher number, dot 6. Okay, so we've got a dotted line around here that basically just represents that we're going to be running some routing protocols there. In this case, the IGP, or the underlying routing protocol, will be OSPF. That's an open standard, and will be area 0. And then we're going to build up MPLS across that, and that'll basically be an IBGP session using the VPN v4 address family. And that'll be using autonomous system number 64512. So if you're not familiar with all these, don't worry about that right now. I just kind of want to let you know that this is what we're going to be working with. So we've got our PEs, that's our provider edge for our MPLS backbone. We're going to go ahead and also connect those. Those are connected to the customer networks, which we're going to call CE. So CE1A, that's going to be customer 1. It's going to be customer, number 1 and site 1. CE1B is going to be customer 1 site 2. And then we've also got customer 2. So we've got customer 2 site 1 and customer 2 site 2 over here. So I wanted to do that because we're going to be running a couple of different scenarios here. There's some interesting things that we can do with MPLS, and I want to kind of expose you to those different features. So what you'll notice here is we're going to be connecting PE1 over to customer 1 site 1, also with a gigabit Ethernet link. That'll be gig 01 on the PE. And that's going to go to a Cisco 3750E. That's actually a layer 3 switch. So that's something that will run layer 3. It will run routing protocols, but it actually happens to be a switch as opposed to a full-blown router. However, it performs everything we need it to do, and it works really well for what we want to do, and that's why we're using it. So you'll notice that on customer 1 site 1, we've got IPv4 addresses. So the L0, that's a loopback 0. That's going to be a 172.16.0.1/24. Now you might be wondering why we're using a /24 for a loopback if you're familiar with networking. The reason I'm doing that is just because I'm going to be using that to emulate what would be the customer, like the client network, if you will. So I don't actually have any endpoints connected to these switches, and that would be required if we were going to say set up an SVI, or basically is just a layer 3 switch virtual interface for a VLAN. So if we don't have something connected, that won't come up and it won't advertise the routes. So I'm going to use loopbacks, which will emulate that, and we'll be able to see the routes go back and forth. And that gives us everything that we want without any additional complexity there. So we do have IPv4. We've also got the link that's going between CE1 site 1 and then also PE1. You'll see here gig 101. That's got two addresses we're going to be assigning. So we've got the IPv4 address, which is 192.168.0.0/30. .1 will be the PE and .2 will be the CE. But we've also got IPv6 set up here. So we're going to be running IPv6 for customer 1. The loopback address will be 2001:101:1/64. That's what we're going to allocate to that. And then it'll have a transport of 2001:100::/126. And then we'll be using ::1 for the PE1 and ::2 for the CE. Now, we will be setting up routing between the CE and the PE, and that's definitely required when we're doing this type of configuration, and that's so that the customer networks can route. In this case, we're going to be using eBGP. That's the most common way that this is done in the industry. It is possible to use a number of other routing protocols, but most often the service provider who would be managing the PE devices, they're going to require you to run BGP. So there's actually two different ways to do that. The one that we're going to be using here for customer 1 is where each of the customer sites has a specific unique ASN per every site. So here, customer 1 site 1 will have an ASN of 65,000, and then customer 1 site 2 will have an ASN of 65,001. Now the MPLS backbone provider is always 64512. That's going to be what that address is assigned. The 64512 and the 65,000 and so forth, that's all private ASN. That basically the BGP private ASNs, and I'll get into this in further videos, are 64512 through 65535. So I just chose to use the private ones. Now I told you that there's a difference between customer 1 and customer 2. As you'll see here, each in customer 1 they have unique ASN 65,000 and 65,001. However, there's another way to do this also, and customer 2 will use that way, and that's to have the same ASN across all the customer 2 sites. So in this case, we'll be using 65535 for both customer 2 site 1 and for customer 2 site 2. So we'll be using that, and I'll explain the different things that need to be done to be able to make that function. And I'm showing this because the different providers out there in the industry, some of them require you to use separate ones, and some of them they don't. They actually want you to use unique ones. So I believe Verizon actually makes you use the same one over and over, and then AT&T requires unique ones. And there's a lot of other service providers obviously out there, but I just want to expose you to both of those different ways of doing this. So one other thing you're going to notice here is customer 2 has a second link, and that's the gig 102, and then that's going to go over to the PE. And what this is doing is this is going to show you an additional feature that service providers use, and that feature is simply the layer 2 Ethernet services. So a layer 2 Ethernet service will allow customer 2 site 1 to have a network. In this case, we'll be using VLAN 5. And that same exact network, that same exact broadcast domain, if you will, that layer 2 network, will be present at customer site number 2 for customer 2. So VLAN 5 will exist on both customer 2 site 1 and customer 2 site 2. And this is something that is coming more and more common in the industry, especially with a lot of the virtualization with vMotion and things like that under the VMware where workload needs to be moved around. Sometimes there's a need for a layer 2 extension. So I'm just going to go ahead and present that to you. Okay, so let's just go ahead and look here as we look around a little bit more. Let me just show you a little bit more of the diagram. There's IP addressing that's basically assigned down here. There's major IP block and then the addressing. This is for the MPLS backbone itself. Again, the MPLS backbone is PE1 and PE2. So that's all allocated here. We've got the IPv4. This is the PE to CE assignments. That's basically where we're going from the provider edge to the customer edge. And that's where we're going to basically be using that IP space. And then we also have IPv6 IP assignments that are going to be used for PE to CE. And then you can see here we've got the for the different customer networks. So we got customer A will be using 172.16.00/16 from that pool, and customer B will be using 172.17.00/16, and that's for IPv4. And then for the customer, we'll also be using some IPv6. There'll be some VRFs. I'll go into VRFs in more detail and through the videos, but a VRF is basically a virtual routing and forwarding instance. Each customer gets their own VRF, and in this case we'll have a VRF for customer 1 with the route distinguishers and route targets. That'll be the assignments we use, in customer 2 has assignments for route distinguisher and route targets. Okay, so that's mainly what we've got here. I mean, it's pretty straightforward. We'll be going through this back and forth. I'll go through the command line and I'll come back to here. We'll explain everything as we go. So if there's anything here that you're not familiar with what I've gone over, don't worry about it. I will explain it in detail as we go. I'll show you how to verify that the different functions are working, and we'll build it in a real structured way. We'll actually start out and we'll look at physical interfaces. We'll assign IP addresses, then we'll test those interfaces, and I'll explain the reasons for that as we go. So we'll go ahead and we'll get started here and start working on the command line, and I'll take you through that also. So let's take a look at that now. Okay, what I'll be using here to connect to all this equipment is basically what we call a terminal server. Now that just happens to be a router. In this case it's a router. There's other ones, but what I'm using is a router. And it just, I log into this router and then it gives me console access into all the other equipment. So basically from one common point I can access everything. So here I call it term server, and to be able to connect to everything I just I connect to it. So like for example PE1 here allows me to connect to it. Now, once I'm logged in, there is a command sequence that's a little tricky, and I'll explain that. But basically, what you do is once we're logged into equipment like this, we're logged into PE1. If we want to be able to go out and go into say PE2, we actually use the command sequence Control Shift 6. We hold down all three of those keys, then we release it. We press the letter X. And then that takes us back to the terminal server. So just Control Shift 6, hold all three of those down, release them, and then go ahead and hit X fairly quickly there, and it'll bring you back to the terminal server. And then you can go to PE2. So now I can bounce back and forth between say PE1 and PE2. So again, Control Shift 6, release, and then hit X. It'll take me back, and then I can go back and forth. So once I've opened those connections, you'll see that I've got connection 1 in connection 2. So I no longer have to keep typing in say PE1 and PE2. If I want to go to PE1, I just type 1 and hit enter and it takes me in. If I want to go into 2, I just hit 2 and it takes me in. Okay, so As we do all this work, we're basically going to be going through the MPLS workbook. So I've got an entire MPLS workbook that you'll have and you'll be going through, and that will take us through everything that we're doing here. So there's this different steps in there, and then these videos that I'll be doing show you how to go through each of those steps. Okay, before we get started on the command line, I wanted to take you through the MPLS Lab workbook really quick here just to kind of get you familiar with it. So this is the MPLS Lab workbook. Um, we go in here, it's got the topology diagram here on the first page. To log into the equipment, it gives you the credentials, basically username's admin, password Cisco, that's for all the different devices here. And then we go into the lab instructions. So there's a number of different instructions here, they're all numbered. We start out with the MPLS backbone initial setup and addressing, and each section starts out with a summary that explains what we're doing. Now this corresponds to the videos. So through the videos, you'll see there's a number of videos, and there's videos that correspond to each of these different areas. And then down in these areas, there's sections and there's tasks. So the task might say here on PE1 and PE2, apply the base configurations for I below in the appendix. The configurations are explained line by line in the MPLS backbone initial setup and addressing video, which is this video right here. So some of the configurations, they may need to be copied in small sections like 10 or 20 lines so the buffer does not overrun. So I'll explain things like that as we go through. And we'll get into bigger tasks like PE1, configure the loopback 0 IP address per the diagram. So we'll go in the diagram, we'll look at the loopback PE1, well, we'll see, okay, it's 10.0.0.1/32. And then we'll build that configuration. I'll take you through there and show you how to do it. So every one of these steps is shown in the video, so you don't need to worry like, what do I do here? Everything is shown. If you go through the video, you'll know exactly what to do, and you know exactly why we're doing it. And not only that, but you'll know how to test it to make sure that it's working, what that output should look like. So there is setup, and then there's also some validation. So we'll go through all of that. Now I did say down at the bottom there's an appendix, and there is. And in the appendix, you'll see that there's base configurations for all the different devices. Now I do on this initial video take you through the step-by-step each command and what the commands are doing, but I do that one time. I don't take you through the base config every single time and type it in by hand manually. If I was to do that, it would just waste a lot of your time and my time too. So I will take you through there and explain what these commands do, and then just like you see in the workbook, you could just basically copy and paste that in, and then each of the different routers would have it. So PE2, and then the customer ones too, so CE1A and so forth. So these are the base configurations. They really don't do anything as far as it goes with routing and communications. This is just general stuff, administrative stuff. It might be like the host name and then the different service features that are inside a router for marking logging events, or if we were going to do debugging, marking that down, things like that. And also for logging into the equipment. So it goes through that and a little bit of hardening, and I'll explain that. So I did want to show you the MPLS lab workbook. In addition to the workbook, there is a solutions manual. Now the solutions manual is probably not given to you outright because it would just give you all the answers. So the lab workbook here takes you through all of the different features that you need to do, and then the videos will explain why you're doing them. At the end, if you ask the instructor, they can give you the solutions manual, and then you could actually look at, were there anything outstanding, or if you didn't understand something properly for an exact task, it will actually tell you what to do. And then again, there'll be an area that shows you how to test that. Okay, so that's basically it for the lab workbook. It is quite long, but it gives you a lot of information, and it's really good to work through. It's well detailed, and it's well planned. Okay, so let's go ahead and we'll go next to the initial configuration. What we'll be doing is we'll be applying the base configurations to the MPLS backbone routers. Those are the PEs. Okay, so let's go back to the diagram here. Like I said, we'll bounce back and forth between the diagram and the command line. So we're going to be working PE1 and PE2 on this initial video. And what we'll be doing is we'll go ahead and set that base config like I just showed you. We'll go ahead and go through that line by line. I will type it out, each one line by line. And then we'll go ahead and also do the same thing for PE2. And we'll be setting up the initial IP addressing for here. So we'll be configuring the loopback addresses on both PE1 and PE2. And we'll also be configuring the gig00 and the gig000 interfaces. And the IP addresses are here. So that will be it for the first one. We will not configure the PE to CE links. Those are the gig01 and the gig02 interfaces. Those will be done on a future video. What we're going to be focusing on is just the MPLS backbone first. So we need to set up the backbone obviously before we can connect any customers to it. And to set up the backbone, there's a fair amount of work. So we'll break it down step by step, like I said, and we'll start out with PE1, PE2, and configure that MPLS backbone. Okay, so let's go ahead and get on the command line here. Okay, so we're back to the terminal server. So let's get on PE router 1. Okay, so you can see here, this is just completely brand new, almost out of the box. It's completely factory reset. So do we want to enter the initial configuration? I don't want to run through the wizard, so I'm going to say no to this. And that'll take just a second for it to process. So while that's processing, I'm going to go ahead and do the same thing here on PE number 2. All right, let's give it a second here for it to finish its cycle. All right, so we're here. We want to be able to start the work on this router. So right now we're not in a prompt in a mode where we can start any kind of configuration or do anything. So we want to go in a privileged exec mode. To do that, we just type in enable. Now that can be shortened to just EN. What will happen is we'll be going through a number of commands here, and I can actually shorten the commands out and then tab them. For example, instead of typing in show run, I could actually just type in SHO run, and it would do the same thing. But I'm going to be typing this out in long ways. That way you can see what the commands are doing and not wonder, hey, what was that command or why did we do that? So I'm not doing that for any other reason than just to be able to teach you. Once you get used to it, you can do it much faster by keeping the command short. So this here is the Cisco 2921 router. This is PE1. Let's go ahead and look at a couple of things here. So the code we're running is 15.3.2T3, and this is a universal code, means that it has all the different features available. However, this router requires a special license. So in order to be able to run MPLS, we actually need to have the data K9 license, just a data license. The K9 is the encrypted one, or we can do that. Sometimes the K9, they don't allow that to be exported to some countries, which is why there's the two different ones, but we're going to be using the K9. And you'll see that that's permanent, that's in use, it's permanent, it's something that we've got loaded. So without that, we wouldn't be able to run the MPLS commands. The router just wouldn't accept them. So it is something that's necessary, but for the purposes of this lab and for the equipment you'll be working on when you're doing this, these licenses are available. Okay, so I'm just going to show you the configuration here. This is just factory default right out of the box. You can see that that's what we've got right there. Okay, so one of the first things we're going to do is we're going to go into configuration mode. So we're going to say config terminal. Okay, so now we're going to go into that mode. Now we're in a configuration mode, and we're going to type in some commands here. Okay, service Nagel. What that is, that's just a congestion control algorithm that helps process the TCP sessions to the router. And without it, every single packet is sent for, there's a single packet sent for every keystroke, and that's really inefficient. So a service Nagel, it'll actually send in multiple keystrokes with the packet, so it just makes it a little bit easier to process. No service pad, I turned that off. That's something that's not used anymore. That was for the old X.25 protocol. That was just legacy. We just don't use that anymore. So service TCP keep alives out and also in. And what that does is that just sends keep alives to verify that the remote side of the TCP connection is active. And it is just really preventing half-open connections to the router or from the router. So it keeps track of those and it prevents the orphan connections. Okay, so I'm going to hit that command. You'll notice you can hit up the up arrow and you'll get the last command. I'll be using that sometimes. You can actually, it gets pretty handy. So for example, we're going to be using this command here, and you'll notice we'll be using that for logging and for debugging. So um, what we're doing here, service timestamps, debug, date time, msec, local time, show time zone, and then also equivalent is service timestamps, log, date time, msec, local time, show time zone. That's just basically setting up for logging and debugging purposes. When we look at the log, we'll have the date and time in there. We'll also have it down to that will show the local time and the time zone, and it'll be down to the millisecond. So that way it gives us really accurate time, very consistent, especially if we sync this up with NTP or some kind of time synchronization protocol. Okay, service internal is something I've been using for years. It just gives us access to additional debugs that normally wouldn't be available in case we need them. We probably don't need them here. However, I turn it on. It's just a part of my general config, my general base config. Okay, the service disable IP fast frag. That is just to disable the fast. It's disable IP particle based fast fragmentation. Okay, service sequence numbers. That just puts sequence numbers on like your log messages. That way you can see everything in sequence. You know exactly what's going on there. Okay, so for the PE routers here, I'm going to be configuring no service DHCP because we're not going to be using DHCP, so I actually turn off the DHCP service on this router. Okay. Okay, service password encryption, that's actually pretty important. So service password encryption actually encrypts your passwords. And that way they don't just show up as the actual plain text password in the configuration. Now don't be mistaken, that is not actually a very strong encryption. It's just basically what they call over-the-shoulder encryption. So if somebody's walking past and they look at the password or while you're working on the configuration, they don't see what the actual password is. But it's decoded very easily. So there's tools that can do it, and you can actually decode it on the router quite easily for the level 7 passwords. Okay, so let's put in a host name. This router here is going to be called PE1. So I'm going to increase the logging buffer to 32,768 bytes. That'll basically give us a lot more information, a lot more by default. Otherwise, it'll just roll really quick. And I like my logging buffer to go all the way through debugging. So it has all the different levels, warnings, notifications, and all the way through debugging. That way I get absolutely everything in the logging buffer. Okay, no logging console. That makes it so as I'm through the console here, I don't get hammered with messages. So you'll see some of these messages like we got here, they're being shown to the logging console. Sometimes that gets in the way. So I actually turn it off. And I don't just turn it off because it gets in the way. Some people like to see it so they know when they've made a mistake or something's happened, they can see it. But it can actually cause a problem if you're doing debugs or something like that. If it's logging to the console, that's a CPU interrupt all the time, and you can actually lock yourself out of a router by overwhelming it. So I turn it off. And also no logging monitor. That turns off for if I was to SSH, like a remote session through SSH or something into the router. That turns off the logging for that. So I'm going to go ahead and set a secret. Enable secret is just a password. That's actually an MD5 password by typing secret. That's much stronger than the enable password command. So we'll do enable secret, and the password will just be Cisco, all lowercase. So we'll set the time zone to PST, and that's -8. Okay, set the summertime for the recurring. Turn on IPsec, and that's the Cisco Express 40, and that's basically used for when we're doing all the routing and the routing table and so forth. That sets up those the Ceph adjacencies. Okay, this is an important one, no IP domain lookup. If you mistype a command or something like that, it actually thinks you're trying to connect to something, and you don't get access back to your console for about 30 seconds while it's doing that lookup, and it's just a real pain. Okay, IP domain name mylab.com. I'm just setting a domain name of mylab.com. We need that because we're going to be configuring some SSH keys in a little while, and when we do that, we actually need to have a domain name. Okay, we're going to set up a username. It's going to be admin. We're going to give him privilege 15. Privilege 15 is the highest privilege level. We're going to set up the secret to be Cisco. So now our username's admin and our password Cisco, which is exactly like I have in the workbook there for you. Okay, IP TCP SYN wait time 5. What that does is if we try to connect to something and it's not available, it'll only wait 5 seconds. So by default, it waits about 30 seconds, and it's really frustrating if you put in the wrong IP or you try to connect to something and it's not up. You have to wait a really long time before it gives you access to your prompt again. So I set this to 5. It's something I do on all the routers that I work on. Okay, IP SSH authentication retries 5. What that's for is if you try to connect to this and you don't authenticate properly in 5 times, it'll disconnect you. Okay, it did give us a message here. It says please create the RSA keys to enable SSH and to use at least 768 bits for SSH v2. And we will be using v2, but right now I'm just setting up some of the SSH commands. We'll build the keys in a little while here, so let's just ignore that message for now. So we're going to be using version 2 like I said. Here. Okay, for this next command we're going to be turning off CDP. So I want to just come back to the diagram here real quick. So what we'll be doing with CDP, that's the Cisco Discovery Protocol. We'll be working on PE1 and PE2 here. So we don't want Cisco Discovery Protocol, which gives information about the router and IP address on it and so forth. We don't want to give that to the customers. So we're just going to turn it off globally. And what that's going to do is it's just going to prevent that from going out anywhere, either the customers or even the PE. So that's just for some good security practice there for what we're doing. Okay, so I'm going to go ahead and come back here to the PE. We're going to say no CDP run, and that'll turn that off globally. Okay, another hardening technique we want to use is no IP HTTP server. That's going to turn off the web interface to the router for HTTP. And we can also turn off the HTTPS, so secure dash server. That will turn that off. Okay, we want to set a banner. We'll set banner exec, and we'll use the caret here. That's the shift 6, and that's going to be our delimiter. So when we're done, we'll go ahead and enter that again, and it'll know we're finished. Okay, so what we're doing here on the banner exec, just when we log in, we get the executive command comes up, the prompt. It'll let us know, hey, this is PE1, this is provider edge router, and this is for data center 1. Okay, so we'll also set a banner login, and this is just what, before you actually log in, it'll be just a warning for anybody who's trying to get in. Okay, no unauthorized access. All right, the next steps, what we'll be doing is just go ahead and configure our access to the device. We'll start out on the console. So to do that, we go into line console 0. We'll go ahead and set a password of Cisco. Set up logging synchronous. and login local. The login local just uses that username and password that we had set up there a little bit earlier. So we'll go ahead and set up the line VTY 0 through 4. I just do line VTY 0 through 4. There's actually 0 through 15. But this gives us 5 different logins at the same time on the device. So never needed more than that. So I use 0 through 4. I see that's very common in the industry. So this is if you were going to SSH into the device, this is how you come in, is through the VTY lines, the virtual terminal lines there. So again, the password Cisco, logging synchronous, login local. Okay, so we're going to say transport preferred is SSH, the input is SSH, and the output is SSH. That means that we'll only accept SSH connections both inbound and outbound. So if we were actually SSH in this device, we want to go somewhere else, we can only SSH out. Okay, so line VTY 5 through 15, we're going to go ahead and disable those. So we're going to say transport input none. That effectively disables the VTY lines 5 through 15. We'll say output none. And there we go. Okay, so that's our base config there. We've gone ahead and got PE1 done. We do need to configure the crypto keys. So we can do that very easily. Okay, so we'll put in crypto key gen RSA. Okay, we're going to generate the general keys. And we're going to use 1024 bits. Okay, so there we go. That is set up. We'll go ahead and save that. Okay, so here we are. We're done on PE1 with the base config. So we'll go ahead and start on PE2 and work on the base config there. Okay, so here we are on router number 2 for PE2. And we can see here we're running the same version of code as we were on the other one on PE1, so 15.3.2 T3. And this also has the data K9 license. So we look at the configuration. This is just factory default as it would come right out of the box. No config on it at all. So this time I'm just going to go ahead and bring up the configuration that's in the appendix and just go ahead and apply that. So I'll show you when we go through that. We just want to do about 10 or 20 lines of that at a time. Okay. So you'll see I do about 20 lines, that way we don't lose any in the buffer. Okay, so all of those are built. Another way we can build the encryption keys are just crypto key gen RSA. That's a shorter way to do it. We can go ahead and choose 1024 and hit enter, and that'll generate the keys. So that's it for the base config on PE number 2. So again, these are available in your workbook down in the appendix. All you got to do is just go ahead and paste them in there, and then you'll have that. So now we've got the base configuration set up on PE1 and PE2. The last part of this video, what we're going to be doing is just configuring the interfaces and then just going ahead and test those and make sure that they're working properly. So we'll start out on PE1 and we'll go ahead and start the IP configuration right there. Okay, so as we look back here on PE1, we're going to start out and we're going to configure the loopback. So we know the loopback here is 10.0.0.1/32. So let's just go ahead and get that configured here. Okay, so put in the IP address 10.0.0.1 with the subnet mask 255.255.255.255, and that 255.255.255.255 corresponds to the /32. We'll give it a description. Okay, so if you want to run a command from here, you can actually just put the do in front of it when you're in config mode, like I'm showing here. So we'll type do show run interface loopback 0. Now we can look at our configuration there. Okay, so let's go ahead and configure the gig00 link. Okay, let's go back to the diagram. We'll see the gig00 link here. It's going to be 10.0.1.0. This is a /30 this time, and it's going to be .1. So we'll go ahead and configure that, and then we'll configure the gig000 link. We'll see that's 10.0.1.4/30. That's the network, and .5 will be the IP address that we use. So let's go ahead and configure that. Start out with the description. Okay, and the IP address, so this time, since it's a /30, that'll be 255.255.255.252. So we need to activate the interface, so we type no shutdown. That activates the interface. And there we go, now we've got that. I'm going to put in one more command. So the carrier delay msec0, basically there's just no delay. Just when we want the interface down or a link gets pulled, it just takes it down immediately. And then that also ties into some of the routing where it'll help flush the routes immediately upon the link going down. So let's configure the gig000 interface. Now this interface is slightly different. It's actually an expansion card in the 2921, and that expansion card has the ability to do either what we call an SFP, which is like an optical module that goes in there, or it can use the copper interface on there. So it can use either one. In this case, we want it to go ahead and use the copper one, so we need to change it because the default is the optical one. So we do that with the command media type RJ45. Give it a description. Assign its IP address of 10.0.1.5/30. That's 255.255.255.252. Do the carrier delay msec0, and then we'll activate the interface. All right, let's go ahead and save those changes. That's our configuration there, and let's take a look. All right, so we can see here we've got our loopback configured. It's ready to go. Our gig00 link, it's ready to go. And our gig000 link is also ready to go. So let's go ahead and switch over to now to PE number 2, and we'll start the configuration there also. Okay, we'll give it a description. Okay, so I know the IP address, but let's just go back here and look at that. So we've got the loopback 0 is 10.0.0.2/32. And then we'll configure the gig00 and the gig00 links. So gig00 is going to be 10.0.1.2, and gig000 is going to be 10.0.1.6. Okay, so we've got the description, the IP address, set the carrier delay to 0 milliseconds, and then activate the interface. Let's go ahead and configure 000. So again, this one here is the combo card, so we're going to put in the media type command, and then that sets that to copper, to RJ45. Okay, so we got the description and the IP address 10.0.1.6/30, so that's 255.255.255.252. And there we go, that's no shut. Save our changes. And let's just take a look at our configuration really quick here. Alright, our loopback 0 looks good. Our gig 00 also looks good, it's fully configured, and our gig 000 is also fully configured. So at this point, we should actually have some connectivity. So I'm going to go back to PE1, and we'll go ahead and we'll test from there. And let's just take a quick look at the interfaces. So the command show IP interface brief, that will show us our interfaces, and then we can look at the status. So we can see here the gig 00 link, it's got an IP address, the right one assigned, and it's actually up, so the status is up and the protocol is up. And we also looking at the gig 000 link, the IP address up, and then the loopback is also IP address assigned, it's up and it's up. Okay, so that's good there. We can actually look and get more detail on the interfaces. We could just look at show interface 00, then it'll give us more detailed information, so we can see that it's up. We can see that here's the address, the description, and then we can also get some information on the how the interface is performing. Are there any kind of input errors? Are there any kind of drops, like we'll see here? So we could get a lot of different information on this. So we can also look at the, it's running a full duplex at 1 gig, and the media type and so forth. So you get some more detailed information by looking at the show interface command. The real big thing we're looking for right now is that it's up and it's got the right IP address. Okay, so let's go ahead and do that also for the gig 000 link. Show interface gig 000, and you'll see that it's also up, which is exactly what we want. So that's a good sign. At this point, what we could actually do is we can actually go ahead and try to ping across it. So if we go and look at the diagram here, we are on PE1, and we want to go ahead and ping from our gig 00 router down to PE2 to that router. So 10.0.1, we want to ping .2. So 10.0.1.2, we want to try to ping that. Then we'll try the other link, which will be 10.0.1.6. So let's see how that goes. Another thing you could do if you didn't want to go back to the topology diagram, obviously you could just show the interface, and then you know that it's the next IP address for the increments from here, so you could say ping. Okay, so there we go, there's our test. You'll see here an exclamation mark as it succeeded. That was successful ping, and we got a response back. A dot means that we didn't. So when you're doing this, sometimes the first one, or I've even seen sometimes the second one, when it's running through the address resolution protocol, it's trying to ARP for the other side. It's not in the table yet, so that ping won't work until it's there. However, that's just the initial piece. Once there's traffic going across, that loads it in the ARP table, and then your pings are successful. So just like you can see here, we've got that working for all 5. So let's go ahead and try the other link now, and it's doing the same thing. So there we go. We've got connectivity now between both PEs. So another thing we could do, just to make sure that these interfaces are working properly, is we could just go ahead and clear the counters. That'll clear all the interface counters. So now all these counters have been cleared, so we've got just one packet output instead of all the other ones. We can run an extended ping. This is a way just to make sure your interfaces are working properly. So we can say ping.10.0.1.2, size, let's just say 1450, and that timeout 1 and a repeat of, let's just say 5,000. Okay, what that's going to do is it's going to send a number of ping packets, decent sized ping packets over to the other side. And then what we can do is we can look at the interface and make sure that it's working properly. Okay, so you can see we sent all that traffic. We don't have any input errors, which is good, and we don't have any drops. So this here is the size is 0, max 75. Our drops is this line right here that I'm highlighting, so that's 0. And so that's good. We don't have any errors there. We don't have any input errors, no runts, giants, anything like that. And it's all clean. There's no collisions or anything. We would not expect any collisions on a full duplex interface. However, there you go. There's the information. So we could also do the same thing for gig 000. So we could just hit the up arrow there. And now we'll go to .6. So we'll run the same command, but we'll run it for .6, which is going to be the second link. We'll hit enter. Okay, and you see we have a success rate of 100%. Out of 5,000 sent, we received 5,000. We had a minimum millisecond round trip time of 1. The average was 1, and there was something maybe at the beginning one that was at 20. So, and we look at this interface, and we can also see that it's running clean. So there's no input errors, no output errors, no collisions, and there's no drops. So that's exactly what we wanted to see, and that's excellent. So that puts us in a good spot. In the next video, we'll go ahead and start continue building the MPLS backbone. So that wraps up what we've got here. Again, this video here, we've now gone ahead and put the base config on PE1 and PE2, and we've assigned the initial IP addresses between for the loopbacks and for the interfaces here, and we verified that those interfaces are working. It's important that we test like we do here. That way we know if there's something wrong, we can address it now. If we start building all this routing and all this different functionality on there and it's not working, it becomes much more difficult to try to identify where the problem is. So by building like this, step by step in a very logical manner, it works really well for making sure that it works properly and that you don't have any errors. It's just a really clean way to do it. Okay, so I'll see you back on the next video.